Okay, example 6 is a nice question, and the more you practice these, the more you'll recognise kind of what you need to do here. But it says simplify the expression. Now, you can see here you've been given a fraction. You want to deal with that like you would deal with a normal fraction. You keep the first one the same, you change your sign, and you flip or you take the reciprocal of the second fraction. And that's going to do that. So we're going to keep the first one the same as 2x squared over 3yz. We change your sign to multiplication and we take the reciprocal, we flip the second fraction, which is 5z squared over 4xy squared. Now, multiplying fractions is really easy. You multiply the numerators together and then the denominators. So if we look at the top part, so this times by this, all of it, well, 2 times 5 gives you 10, and then x squared times by z squared, well, you're timesing, you just group it all together. So you just write it as x squared z squared. So if you're timesing, you can just group things together. You can't do that with addition or subtraction. And that's all over the bottom. 3 times 4, which is 12. You've then got y times by, so you've got y times by y squared, which is y cubed. Okay, adding the powers 1 and 2. And you've got z, and there's no z over here, so we can just write the z over here. And we've got x here and no x here, so we're just going to go and write it as x. Okay, that z's a bit confusing, that's a z down there. Okay, now just being a little bit picky here, I'm going to actually leave it. I might have written this in alphabetical order, x, y, z. I haven't, but it doesn't really matter because remember, multiplication is commutative. The order doesn't matter, but it would be convention to write to x and y and z. But we'll keep moving. Now, I've done one stage of it. I've written it as one fraction, which is useful, but I've got to simplify it. And again, I can do that by looking at the number parts, 10 and 12. What's the highest common factor of 10 and 12? 2. 10 divided by 2 gives me 5, and 12 divided by 2 gives me 6. So 5/6. Okay? Now, on the top, I'll highlight the next parts to make it a bit clearer. We've got x squared, and we are dividing by x. Okay? Now, again, dividing, we take away the powers. So you've got 2 take away the power of 1, which gives you x to the 1, which is just x. So 5/6 x. We can then look at the z parts. Okay, so we've got z squared divided by z to the 1 again, which will just give you z. Okay, so we've got z over here. And you just got a y cubed on the bottom. Okay, so what you could do here is, you could write it as this. You could write it as 5xz over 6y cubed, because the y cubed is on the bottom. That's fine. That's one way of writing it. Or you could write it like this. You could write it as, knowing that from your laws of indices, again, that we've just seen on another question previously, if you've got a number like x to a negative power, you write it as 1 over that number to the power. So the y cubed, if you've got 1 over y cubed, which is effectively this part here, okay, that means 1 over y cubed, you can write it as y to the minus 3. They mean the same thing. So you could also write this part here as 5 over 6 x y to the minus 3 and then z. They mean exactly the same thing. And personally, I would write it in this way because why do I write it in this way? Really doesn't actually matter. It's just because this part here is in one line, but there is really no preference here. What does the book go for? The book's gone for 5 over 6xz over y cubed. Okay, it's gone for this one. Yeah, but this definitely means the same thing. Okay, but either of those is correct. So just to make it really clear for you guys, either this one or this one. But it's good because you can really think, right, okay, these things here, right, they mean the same thing because the y cubed here is on the bottom of that fraction. You've got this situation here, which you can write as y to the minus 3. Good stuff. Okay, that is example 6.